Good day, everyone. I'm Marshall Irish Parale, and I will present Chapter 14 Managing Projects. After the presentation, you will be able to answer the following question. What are the objectives of project management and why it is essential to developing information system? Number 2, what methods can be used for selecting and evaluating information system projects and aligning them with the firm's business goals? Number 3, how can a firm assess the business value of information system? And lastly, what are the principal risk factors in information system projects and how can they be managed? So, what are the objectives of project management and why it is essential in developing information system? Project management refers to the application of knowledge, skills, tools and techniques to achieve a specific target within the specified budget and time constraint. The importance of project management is it helps every part of the business runs more smoothly. It allows your team to focus on the work that matters, free from the distractions caused by the task going off track or budget spinning out of control. Runaway project and system failure. The traditional definition of runaway is any project that grossly exceeds budget and time target but yet has failed to produce an acceptable deliverable. There's a very high failure rate among information system projects. Information system initiative takes longer and costs more than expected in almost every business or they don't function. When an information system doesn't fulfill expectation or costs too much to construct, firms may not gain from their investment and the system may not be addressed the intended issue. The manner a project is conducted will likely have the most impact on its result. It is important to know how to manage IT projects and why they succeed or fail. Runaway project in system error in continuation, a joint study by McKinsey and Oxford University found that large software projects on average run 66% over budget and 33% over schedule. Over 15 Over 50 of the business recently surveyed by cloud project portfolio management provider Inotas has experienced IT project failure within the previous 12 months, according to Florentine 2016. Consequences of poor project management. As illustrated in the figure, a system development project with a proper management will most likely suffer these consequences. Costs that vastly exceed budgets, unexpected time slippage, technical performance that is less than expected, failure to obtain anticipated benefits. The system produced by failed information projects are often not used in the way they were intended or are not used at all. Users often have to develop parallel manual systems to make this system work. With a proper management, a system development project takes longer to complete and most often exceed the allocated budget. The resulting information system may not be able to demonstrate any benefits to the organization. Project management objective. A project is a planned series of related activities for achieving a specific business objectives. System projects includes the development of new information system, enhancement of existing systems, or upgrade or replacement of the firm's information technology infrastructure project. Project management refers to the application of knowledge, skill, tools, and techniques to achieve a specific target within a specified budget and time constraint. Project management activities include planning the work, assessing risks, estimating resources required to accomplish the work, organizing the work, acquiring human and material resources, assigning tasks, directing activities, controlling project execution, reporting progress, and analyzing the result. As in another areas of business, project management for information system must deal with five major variables: scope, time, cost, quality, and risk. Scope defines what work is or is not included in a project. For example, a new order processing system may have new modules for entering orders and sending them to production and accounting, but no modification to accounts receivable, manufacturing, distribution, or inventory management system. Project management outlines all the work required to execute a project properly and should guarantee that the scope of a project does not go beyond what was initially planned. Time is the amount of time required to complete the project. The project management determines the time needed to accomplish important component. Each component has activities and duties. Project management estimates how long each job will take and creates a timetable. Cost is based on the time to complete the project multiplied by the cost of human resources required to complete the project. Information system project costs also include the cost of hardware, software, and workspace. Project management develops a budget for the project and monitors ongoing project expenses. Quality is an indicator of how well the end result of a project satisfies the objective specified by management. The quality of information system project usually boils down to improve organizational performance and decision making. Quality also considered the accuracy and timeliness of information produced by the new system and ease of use. This refers to the potential problems that will threaten the success of project. These potential problems might prevent a project from achieving its objectives by increasing time and cost, lowering the quality of project outputs, or preventing the project from being completed altogether. What methods can be used for selecting and evaluating information system projects, aligning them with the firm's business goal? Companies get several initiatives to solve problems and improve performance. System project ideas outnumber resources. Firms must choose the most beneficial ventures. Business strategy should drive project selection. How should manager choose among all the options? The figure shows the element of the management structure for information system projects in a large corporation. It helps ensure the most important projects are given priority. At the apex of this structure is the corporate strategic planning group and the Information System Steering Committee. The Corporate Strategic Planning Group is responsible for developing the firm's strategic plan, which may require the development of new systems. Often, these groups will have developed objective measures of firm performance and choose to support IT projects that can make substantial improvement in one or several key performance indicators. These performance indicators are reviewed and discussed by the firm boards of directors. The Information Systems Steering Committee is a senior management group with the responsibility for system development and operation. It is composed of department heads from both end user and information system areas. The steering committees reviews and approve plans for system in all divisions, seek to coordinate and integrate system, and occasionally becomes involved in selecting specific information system project. This group also has a keen awareness of the key performance indicator decided by the higher level managers and the board of directors. The project team is a supervised by project management group composed of information system managers and end user managers responsible for overseeing specific information system projects. The project team is directly responsible for an individual system project. It consists of system analysts, specialists from the relevant end user business areas, application programmers, and perhaps database specialists. The mix of scale and the size of the project team depend on the specific nature of the system solution. Linking system project of business plan. In order to identify the information system project that will deliver the most business value, organization need to develop information system plan that supports their overall business plan and in which strategic systems are incorporated into top level planning. The plan serves as the roadmap indicating the direction of system development. The purpose of the it is the purpose of the plan. The rationale, the state of current system, new developments to consider, the management strategy, the implementation plan, and the budget. This is the sample of information system plan. The plan contains statement of the corporate goals and specifies how information technology will support the attainment of these goals. The report shows how general goals will be achieved by specific system projects. It identifies specific target dates and milestones that can be used later to evaluate the plan's progress in terms of how many objectives were actually attained in the time frame specified in the plan. The plan indicates the key management decision, technology, and required organization changes. In order to plan to effectively, firm will need to inventory and document all the information system application, IT infrastructure, components, and long and short-term information requirements. For projects in which benefits involve improved decision making, managers should try to identify the decision improvements that would provide the greatest additional value to the firm. They should then develop a set of metrics to quantify the value of more timely and precise information on the outcome of the decision. Once strategic analysis has determined the overall direction of the system development, portfolio analysis can be used to evaluate alternative system projects. Portfolio analysis is the process of reviewing or assessing the elements of the entire portfolio of securities or products in a business. Portfolio analysis inventories all of the organization's information system projects and assets, including infrastructure, outsourcing contracts, and licenses. This portfolio of information system investment can be described as having a certain profile of risk and benefit to the firm, similar to a financial portfolio. Each information system project carries its own set of risks and benefits. Firm will try to improve the return of their portfolio of IT assets by balancing the risk and return from their system investment. Although there is no ideal profile for all firm information intensive industry such as finance, it should have a high risk, high benefit project to ensure that they stay current with technology. Firms in non-information intensive industry should focus on high benefit, low risk project. Most desirable, of course, are systems with high benefit and low risk. This promise early returns and low risk. Second, high benefit, high risk system should be examined. Low benefit, high risk system should be totally avoided. And low benefit, low risk system should be examined for the possibility of rebuilding and replacing them with more desirable system having higher benefits. By using portfolio analysis, management can determine the optimal mix of investment risk and reward for their firms, balancing riskier, high reward projects with safer, lower reward ones. Firms where portfolio analysis is aligned with business strategy have been found to have superior return on their IT asset, better alignment of IT investment with business objective, and better organization-wide coordination of IT investment, according to Jeffrey and Lillyville 2004. Scoring model. Scoring model is a tool you use to align a comparative value to one or more project tasks. A scoring model is useful for selecting projects where many criteria must be considered. It assigns weights to various features and systems and then calculates the using weighted totals. The firm must decide among two alternative enterprise resource planning system (ERP). The first column lists the criteria that decision makers will use to evaluate the system. These criteria are usually the result of lengthy discussion among decision making group. Often the most important outcome of scoring model is not to score, but agreement on the criteria used to judge a system. The table shows that this is an example of scoring model for an ERP system. The table shows that this particular company attached the most importance to capabilities of sales order processing, inventory management, and warehousing. The second column in the table lists the weight the decision makers attach to the decision criteria. Column 3 and 5 shows the percentage of requirement for each function that each alternative ERP system can provide. Each, each score can be calculated by multiplying the percentage of requirement met for each function by the weight attached to that function. ERP system B has the highest total score. As with all objective techniques, there are many qualitative judgments involved in using the scoring model. This model requires experts who understand the issues and the technology. It is appropriate to cycle through the scoring model several times, changing the criteria and weights to see how sensitive the outcome is to reasonable changes in criteria. Some Scoring models are used most commonly to confirm, to rationalize, and to support decision rather than the final arbiters of system selection. How can firm assess the business value of information system? Even if a system project supports a firm's strategic goal and meets users' information requirement, it needs to be good investment for the firm. The value of system from financial perspective essentially revolves around the issue of return on invested capital. Does particular information system investment produce sufficient return to justify its cost? Information system cost and benefit. This table lists some of the more common costs and benefits of system. Tangible benefits can be quantified and assigned a monetary value. Intangible benefits such a more efficient customer service or enhanced decision making cannot be immediately quantified but may lead to quantifiable gains in the long run. Transaction and clerical system that displace labor and save space always produce more measurable, tangible benefits than management information system, decision support system, and computer supported collaborative work system. Capital budgeting for information system. To calculate the project benefits, add up its expenses and benefits. Costs that surpass benefit should be refused even if the benefit surpass the cost. Extra financial analysis is needed to evaluate whether the project provides a good return on the firm's capital. Capital budgeting is the process business use to determine which proposed fixed asset purchase it should accept and which should be declined. Capital budgeting models estimate the value of long-term capital investment. Capital budgeting methods relies on measure of cash flows into and out of the firm. Capital projects generate those cash flows. The investment cost for information system project is an immediate cash outflow caused by expenditure for hardware, software, and in labor. In subsequent years, the investment may cause additional cash outflows that will be balanced by cash inflows resulting from the investment. Cash inflows take the form of increased sales or more products or reduced costs in production and operation. The difference between cash outflows and cash inflows is used for financial worth of an investment. Once the cash flow have been established, several alternative methods are available for comparing different projects and deciding about the investment. The principal capital budgeting model for evaluating IT projects are the payback method, the accounting rate of return on investment, net present value, the internal rate of return or IRR. Limitation of financial models. Traditional focus on financial and technical aspect of information system tends to overlook the social and organizational dimensions of information system that may affect the true cost and benefit of the investment. Many companies' information system investment decisions do not adequately consider costs from organizational disruption created by a new system, such as the cost to train end user, then the impact the user's learning curves for a new system have on productivity, or the time managers need to spend overseeing new system related changes. Intangible benefits such as more timely decision from a new system or enhanced employee learning and expertise may also be overlooked in traditional financial analysis. What are the principal risk factors in information system projects and how can they be managed? This describes the special risk information system project and show what can be done to manage them effectively. Dimension of project risk. Differ dramatically in their size, scope, level of complexity, and organizational and technical components. Some system developments projects are more likely to create the problems we have described earlier or to suffer delays because they carry a much higher level of risk than other. The level of project risk is influenced by project size, project structure, and the level of technical expertise of the information system staff and project team. Project size. The bigger the project, the greater the risk. The bigger the project in terms of fund investment, fund invested, implementation staff size, implementation duration, and organizational units affected, the higher the risk. Complex, difficult to control, large scale system projects have a 50 to 75% greater failure probability than other projects. The organizational complexity of the system, how many units and organization utilize it, and how much it impacts business processes contributes to the complexity of large-scale system projects project as much as technical characteristic like the number of program lines, project duration, and budget. Few strategies exist for evaluating the time and cost of developing large-scale information system. Structure. Some projects are more highly structured than others. Clear and simple criteria make it easy to specify outputs and procedures. Users know what they want and what the system should do. They seldom change their opinion. Such projects run a much lower risk than those with vague, fluid, and continually changing needs outputs that can be readily modified due to shifting users' notions or users who can't agree on what they want. Experience with technology. The project risk rises if the project team and the information system staff lack the required technical expertise. If the team is inexperienced with the project's hardware, system software, application software, or database management system, technical difficulties or delays are probable. change management, and the concept of implementation. The introduction or alteration of an information system has a powerful behavioral and organizational impact. Changes in the way that information is defined, assessed, and used to manage the organization's resources often lead to new distribution of authority and power. This internal organization change breeds resistance and opposition and can lead to the demise of otherwise a good system. A very large percentage of information system projects stumble because the process of organizational change surrounding system building was not properly addressed. Successful system building requires careful change management. The concept of implementation. To manage the organizational change, surrounding the introduction of new information system effectively, you must examine the process of implementation. Implementation refers to all organizational activities working toward the adoption, management, and routinization of an innovation such as new information system. In the implementation process, the system analyst is a change agent. The analyst not only develops technical solution but also redefines the configuration, interaction, job activities, and power relationship of various organizational groups. The analyst is the catalyst for the entire change process and is responsible for ensuring that all parties involved accept the changes created by new system. The change agent communicates with user, mediates between competing interest groups, and ensures that organizational adjustment to such changes is complete. The role of end user. System implementation generally benefits from high level of user involvement and management support. User participation and in the design and operation of information system has several positive results. First, if the users are heavily involved in the system design, they have more opportunities to mold the system according to their priorities and business requirements and more opportunities to control the outcome. Second, they are more likely to react positively to the completed system because they have been active participants in the change process. Incorporating users' knowledge and expertise leads to better solution. The relationship between users and information system specialists has traditionally been a problem for information system implementation efforts. Users and information system specialists tend to have different backgrounds, interests, and priorities. This refers to the user designer communication gap. Those differences lead to divergent organizational loyalty, approach to problem solving, and vocabularies. This is the user design communication gap. This is the example. Um, Information system experts, for example, are generally machine oriented while tackling problems. They seek slick, sophisticated technological solutions that optimize hardware and software efficiency above user or organizational effectiveness. Users choose business or task focus system. Often, both groups' attitudes are so distinct that they seem to speak in different language. This table compares the concern of end user and technical professionals. Information system designers about new information system. Poor communication between end user and designer is a primary reason why user requirements aren't adequately integrated into information system and why users are pushed out of the implementation process. When users and technical experts have a large disparity in objective, system development initiatives are at a significant risk of failure. In such cases, user leave the project. User decide that the project is best left to the information professionals since they can't understand them. Management support and commitment. If management at all levels back an information system project, user and technical information services wo- workers are more likely to see it favorably. Both groups will assume their development involvement will be prioritized. They will be rewarded for their work. Management support guarantees a system project has enough budget and resources. Changes in work habits and processes, as well as organizational realignments, need managerial support to be successfully implemented. If management deems a new system a priority, subordinates will do. According to the Project Management Institute, executive sponsor who are actively engaged is the leading factor in project success. Change management, challenges for business process, the engineering, enterprise application in mergers and acquisition. Given the challenges of innovation and implementation, it is not surprisingly to find high failure rate in enterprise application and business project process reengineering project, which requires extensive organizational change and may require replacing old technologies and legacy and legal systems rooted in many interrelated business processes. 70% of business process reengineering efforts fail to provide promised advantages according to research. Even after 3 years of work, many corporate applications aren't completely built or don't match user expectation. Poor implementation and change management undermines several corporate application and reengineering effort. Fear and anxiety across the company, key manager reluctance, and altering job roles, career pathways, and recruiting methods constitute larger obstacles to reengineering than imagining and developing breakthrough business process innovations. All enterprise applications demand tighter functional group cooperation and business process transformation. Projects related to mergers and acquisition have a similar failure rate. Organizational characteristic and IT infrastructure of merging organization affect mergers and acquisition. Combining two firms' information system demands complicated initiatives and organizational transformation. If the integration isn't effectively handled, organization might end up with a tangled jumble of inherited old system. With a proper Without proper system integration, merger advantages can't be realized, or the combined organization can execute business activities successfully. Controlling these factors. Specific implementation difficulties demand different project management requirements, requirement collecting, and planning methodologies. Strategies have been developed to ensure users play appropriate roles throughout deployment and to manage organizational transformation. Not all implementation factors can be planned or controlled, or anticipating implementation problems and using remedial techniques may boost system success. The first step in managing project risk is identifying the nature and level of risk confronting the project. Second, not all risks are identifiable in advance, but with skillful project management, most are. Frequent communication in a culture of collaboration will help project teams adapt to unforeseen problems that arise. According to Browning and Ramoses 2015, Loper et al. 2015, and McFarland 1981. Managing technical complexity. Internal integration tools help complicated technological projects. Complexity management determines the success of such undertakings. Project managers may require technical and administrative skill. They must foresee difficulties and build productive connection within technological team. A manager with a strong technical and project management expertise should lead the experienced team. Frequent meetings are needed. Essential technical skills or expertise not available internally should be secured from outside the organization. Formal planning and control tools. Large project benefits from appropriate use of formal planning and tools and formal control tools for documenting and monitoring the plans. The two most commonly used methods for documenting project plans are Gantt chart and PERT chart. These project management techniques can help managers identify bottlenecks and determine the impact that problem will have on project completion times. They can also help system developers partition projects into smaller, more manageable segments with defined measurable business results. Standard control techniques can successfully chart the progress of the project against budgets and target dates. So deviation from the plan can be spotted. Gantt chart lists project activities and their corresponding start and completion dates. The Gantt chart visually represents the timing and duration of different tasks in the development project as well as their human resource requirement. In this table, it shows each task as a horizontal bar whose length is proportional to the time required to complete it. Although Gantt charts show when project activities begin and ends, they don't depict task dependencies. How how one task is affected if another is behind schedule, or how tasks should be ordered. PERT chart. PERT stands for Program Evaluation and Review Technique, a methodology developed by U.S. Navy during the 1950s to manage the Polaris submarine missile program. A PERT chart graphically depicts projects, tasks, and their interrelationship. The PERT chart lists the specific activities that make up a project and the activities that must be completed before a specific activity can start. As you can see in this illustration, the PERT chart portrays a project as a network diagram consisting of number of nodes representing project tasks. Each node is numbered and show the task, its duration, the starting date, and the completion date. The direction of the arrows on the lines indicates the sequence of tasks and show which activities must be completed before the commencement of another activities. In this figure, the tasks in nodes 2, 3, and 4 are not dependent on each other and can be undertaken simultaneously, but each dependent on completion of the first task. PERT chart for complex project can be difficult to interpret and project managers often use both techniques, Gantt and PERT chart. Increasing involvement and overcoming user resistance. Unstructured, undefined project must include users at all phases. User must be organized to support a particular design alternative. External integration tools connect the implementation team's effort to organizational wide users. Users can join the project team, assume leadership roles, and handle installation and training. The implementation the implementation team may exhibit responsiveness by swiftly responding inquiries, implementing comments, and being helpful. User resistance to organization change may not be addressed by participation in implementation effort. The system affects users directly. Some users may embrace a new system because it delivers helpful improvement, while others may fight the alteration because they are harmful to their interests. If a system is optional, user may avoid it. If it's forced, resistance may include a higher mistake rates, interruption, turnover, and sabotage. The implementation approach must promote user engagement and combat counter implementation. Counter implementation is a tactic to stop an information system or innovation from being implemented. User engagement to elicit commitment and enhance design, user education and training management, ethics and policies, and improve incentives for cooperating user may overcome user resistance. The new system can be made more user-friendly by improving the end-user interface. User will be more cooperative if organizational problems are solved prior to introducing the new system. Designing for organization. Because the purpose of new system is to improve the organization's performance, information system project must explicitly address the ways in which the organization will change when the new system is installed, including installation of mobile and web application, in addition to procedural changes, transformation in job functions, organizational structure, power relationship, and the work environment should be carefully planned. Areas where user interface with the system requires special attention with sensitivity to ergonomics issue. Ergonomics refer to the interaction of people and machine in the work environment. It considers the design of job health issues and the end user interface of information system. Um, in the next slide, we will show the table of list of organizational dimension that must be addressed when planning and implementing information system. Although system analysis and design activities are supposed to include an organizational impact analysis, this area has traditionally been neglected. An organizational impact analysis explains how a proposed system will affect organizational structure, attitude, decision making, and organization. To integrate information system successfully with the organization through and fully documented organizational impact assessment must be given more attention in development effort. This is the sample of organizational factors, the planning and implementation. It lists the organizational dimension that must be addressed when planning and implementing information system. Social technical design. One way of addressing human and organizational issues is to incorporate the social technical design practice into information system project. Designers set forth separate set of technical and social design solution. The social design plans explore different work groups, structure, allocation of tasks, and the design of individual jobs. The proposed technical solution are compared with the proposed social solution. The solution that best meets both social and technical objective is selected for the final design. The resulting socio-technical design expected to produce information system that blends technical efficiency with sensitivity to organizational and human needs, leading to higher job satisfaction and productivity. Project management software tools. Commercial software tools that automate many aspects of project management facilitate the project management process. The project management software typically feature capabilities for defining or and ordering tasks, assigning resources to tasks, establishing starting and ending dates to tasks, tracking progress at both individual and team levels, and facilitating modification to tasks and resources. Many automate the creation of Gantt and PERT chart and provide communication, collaboration, and social tools. Some of these tools are large sophisticated programs for managing every large projects, dispersed work groups, and enterprise function. These high-end tools can manage a very large number of tasks and activities in complex relationships. The most widely used project management today is Microsoft Project, but there are also lower cost tools for smaller projects and small businesses. Many project management applications are now cloud-based to enable the project team members to access project management tools and their data wherever they are working. The interactive session on technology describes some capabilities of cloud-based Microsoft Project Online. While project management software helps organizations track individual projects, the resources allocated to them and their costs, Project portfolio management software helps organization management portfolios of projects and dependencies among them. Project portfolio management software helps manager compares proposal and project against budget and resource capacity level to determine the optimal mix and sequencing of the project that best achieves the organization's strategic goals. Review summary. So, to summarize, um, in the questions, what are the objectives of project management and why it is essential to developing information system? Good project management is essential for ensuring that systems are delivered on time and budget and provide genuine business benefit. Project management activities include planning the work, assessing the risk, estimating acquiring resources required to accomplish the work, organization work, directing execution, and analyzing work results. Project management must deal with the five major variables: scope, time, cost, quality, and risk. In question, what methods can be used for selecting and evaluating information system project and aligning them with the firm business goals? Organization needs an information system plan that describe how information technology supports the attainment of their business goals and documents all their system application and IT infrastructure components. Large corporation will have management structure to ensure the most important system projects receive priority. Portfolio analysis and scoring models can be used to identify and evaluate alternative information system projects. How can firm assess business value information system? To determine whether an information system project is good investment, one must calculate its cost and benefit. Tangible benefits are quantifiable and intangible may be immediately quantified, may provide quantifiable benefits in the future. Benefits that exceeds costs should be analyzed using capital budgeting methods to make sure a project represents a good return in the firm's invested capital. What is the principal risk factors that information system project and how can they be managed? The level risk of system development project is determined by project size, project structure, experience with technology. IS projects are more likely to fail when there is insufficient or improper user participation in the system development project, a large management support, and poor management of implementation process. There's a very high failure rate among projects involving business process reengineering, enterprise application, and mergers and acquisition because they are require intensive organizational change. Implementation refers to the inter-process of organization change surrounding the introduction of new information system. User support and involvement and management support and control of implementation process are essential as are mechanism for dealing with the level of risk in each new system project. Project risk factors can be brought under the sum control by a contingency approach to project management. The risk level of each project determines the appropriate mix of external integration tools, internal integration tool, and formal planning tools, and formal control tools to be applied. Project management software help organization track individual project and project portfolio management software helps them manage portfolios of project and dependencies among them. So that's all for managing projects. Thank you for listening.